A warm greetings to one and all. In this session, let's learn about Minimax algorithm with an solved example problem. Minimax algorithm is a powerful recursive algorithm used in decision making in two-player games such as chess, checkers, and tic-tac-toe. It assumes both the players play optimally. That is, one player maximizes the score while the other minimizes it. Minimax helps the players to choose the best possible moves by considering all future possibilities. The Minimax algorithm explores the game tree using depth first search algorithm, that is DFS. The algorithm explores all possible moves down to the terminal nodes and then backtracks using recursion to determine the best outcome. The goal is to find the best value for the root node. It is important because it helps the AI to simulate possible moves and choose the best action. It also avoids random moves and instead it selects the best possible outcome. It ensures strategic gameplay by evaluating future possibilities. It is used in board games such as chess, checkers, and tic-tac-toe. It is also used in AI-based decision-making problems and strategic turn-based simulations. Minimax algorithm is basics for alpha-beta pruning algorithm. Now let's break down the Minimax algorithm. Here the function name is Minimax and it holds parameters namely node, depth, and player. If depth is equal to 0, the function returns the value of the node. Next, if the current player is max, that is maximizing player, it starts by initializing the alpha value to a minimum number minus infinity. Then it iterates through each child node of the current state. For each child, it recursively calls the minimax function while decreasing the depth and switching to the minimizing player min. As the regression progresses, it updates the value of highest score found among the children. That is, alpha is equivalent to max of alpha comma value. Finally, it returns the maximum value of alpha as the best possible score for the maximizing player max. In the else part, it is for minimizing player. It starts by initializing alpha value to a large number plus infinity. Then it iterates through each child node of the current state, and for each child, it recursively calls the minimax function while decreasing the depth and switching to the maximizing player max. As the recursion progresses, it updates the value with the lowest score found among the children. That is, alpha is equivalent to minimum of alpha comma value. Finally, it returns the minimum value of alpha as the best possible score for the minimizing player min. A maximizing player would call it as minimax of start, depth, max. Let's solve an example problem now. Here, the root node A is always max initialized with the value minus infinity because it represents the decision-making entity, that is AI or main player. It tries to get the highest possible outcome. Next, minimum. It represents the opponent, that is node B and node C. It is initialized by infinity. It tries to respond by choosing the worst outcome for max player. Next, the node D, E, F and G represents the max player and initialized by the value minus infinity. This iteration continues through the game tree until the final decision is made. Now we need to expand the game tree from root node A using DFS algorithm till we reach the leaf node. Now we need to move from root node A to node B. Next we move to node D. Node D has two children, that is node H with value -2 and node I with value 5. The evaluation begins by initializing node D as minus infinity. As it is maximizing node, we need to apply max function. The algorithm first compares node H value, that is -2, with the initial value minus infinity of node D. Now, node D is updated with the value -2 since -2 is the maximum value. Next, it compares the node I value, that is 5, with the current D value, that is -2. Since 5 is larger here, node D value is updated as 5 as its final value. This value is then propagated to the parent node B for further evaluation in min-max process. From node B, we move to node E. Node E has two children, namely node J with value 3 and node K with value 7. The evaluation begins by initializing node E as value minus infinity. As it is maximizing node, we need to apply max function. The algorithm first compares J value 3 with the initial value minus infinity and updates the node E value as 3 since it is maximum. Next, it compares node K value 7 with the current E value 3. Since 7 is larger, node E value is updated as 7 as its final value. This value is then propagated upwards to the parent node B for further evaluation. Since B is minimizing node, as we have seen earlier, we need to find the minimum value among node D and node E. That is minimum of 5, 7. Since 5 is minimum value, it is updated for node B. The same value is propagated to node A for further evaluation in min-max process. Now we move from root node A to node C. Then we move to node F. Node F has two children, that is node L with value -4 and node M with value 6. The evaluation begins by initializing F value as minus infinity. As it is maximizing node, we need to apply max function. The algorithm first compares node L value with -4 with the initial value minus infinity and updates the node F value as -4 since -4 is maximum. Next, it compares with node M value, that is 6, with the current F value -4. Since 6 is larger, node F value is updated as 6 as its final value. Then this value is propagated upward to the parent node C for further evaluation in min-max process. Next, from node C, we move to node G. Node G has two children, that is node N with value 1 and node O with value 8. The evaluation begins by initializing node G value as minus infinity, as it is a maximizing node, and we need to apply max function. The algorithm first compares node N value 1 with the initial value minus infinity and update the node G value as 1 since it is maximum. Next, it compares node O value, that is 8, with the current G value 1. Since 8 is larger, node G value is updated as 8 as it is final value. This value is then propagated upwards to the parent node C for further evaluation. Since node C is minimizing node, we need to find the minimum value among node F and node G, that is minimum of 6, 8. Since 6 has minimum value, it is updated to node C. The same value is propagated to node A. Since node A is maximizing node, we need to find the maximum value among node B and node C. That is maximum of 5, 6. Since 6 is the maximum value, it is updated for the node A. The final optimal path is from A to C, C to F, and F to M with the final value 6. That is the optimal move using Minimax algorithm. So hope you are clear in Minimax algorithm with this example problem. Let's check out the properties of Minimax algorithm. Yes, it is completeness. That is, always it finds a solution if it exists. That is, in given enough time and memory. Next, optimality. It always guarantees the best move if both players plays optimally. Next, time complexity. It has order of b to the power of d. That is, it is exponential and expensive for deep trees. Here, B is branching factor and D represents depth. The space complexity is order of B into D. Here, it is reduced via depth first search plus recursion. It works best for the deterministic zero-sum games such as chess, tic-tac-toe. Limitation is there is no learning happened. That is, it evaluates more independently. Thank you all.